Hello calculus students, this section is on finding the average value of a function. Let's first begin with the idea of what's happening here. So we have some sort of function here, we'll say this is f of x. I want you to focus on the amount of area underneath this function over this interval from a to b. Imagine this was a profile view of an ant farm, where what you're seeing here is a thin sheet of sand enclosed in a glass case. Imagine what would happen to the shape of the sand if you were to gently rock the ant farm back and forth. You would expect that the sand would level off and form the shape of some sort of rectangle. The amount of sand would not change though. That's like saying in this picture here, focused on this gray area, what if it were reformed into a rectangle that had the same amount of area? So we're going to have some sort of top of a rectangle, and now let's imagine where that top might be. If this sand settled, it wouldn't make sense that it would make a rectangle this tall. Even this tall doesn't feel right. It would not make a rectangle this tall. That's way too short. It's going to be somewhere, in this region here. And one way to think about it is to park this line where the amount of area that's up here, which is the sand above that line, should be equal to the amount of area that needs to be filled in by that sand. And currently where I'm parked, the blue and the red areas are not the same. That tells me that I want to mentally move this higher. Maybe somewhere in this area. If that were the case, then the amount of area of sand above that line, which is this, looks to be roughly the same as the amount of area below the horizontal line. So in other words, the red sand could be used to fill in the vacant space indicated by the green. And then we would have the sand in the shape of a rectangle instead. Well, the key to this is finding out where that height is. We're going to call this the average value of f. So I'm going to write f sub average. Or in words, this is the average value of f over the interval from a to b. So I'm going to stress the area of this rectangle. And that green shaded rectangle should have the same area as the original gray area. Well, as far as the box is concerned, the dimensions of this box, that height is called the f average, f sub a vg. How wide is the box? Well, we just do the difference of the x coordinates, b minus a, we'll get that width. And we're going to be able to produce a formula for finding the f average because we know that the area of the green box should be equal to the area under the curve, which sets up the following. F average times b minus a should be equal to the integral from a to b of this function. All right, so this part here is the area of the box, the green box, and this is the gray area, and they should be equal. And now we just have to solve for f average. So the average value of the function over this interval, we're going to divide by the b minus a to the other side, and we get a general formula here we can use to find the average value of any function over any interval. And this formula applies even if the function is not always above the x-axis on the interval from a to b. Sometimes a function might dip below the x-axis. If you have some positive y-coordinates and some negative y-coordinates, then you can see the average of those would be somewhere a small positive, small negative, or near zero. It depends on how much positive, how much negative there are. This formula here will give you the average value of any function that's integrable over an interval from a to b. Okay, let's put this to use. Find the average value of the function 3x squared plus 1 over the interval from 1 to 3. Okay, so step 1, the average value of this function will just be the definite integral of this function from 1 to 3, and then we divide by the length of the interval. This interval has length 2, so we divide by 2, or multiply by 1/2. And so in this case, we get 1/2 times, and now let's go ahead and do the antiderivative. The antiderivative of 3x squared is just a clean x cubed. The antiderivative of 1 is x, and that's going to be evaluated from 1 to 3. Let's plug in 3 first. We get 3 cubed is 27 plus 3 is 30, and then subtract. Now plug in 1. 1 cubed plus 1 winds up being 2. So we get a 28 in there. We wind up getting a 14 after I do the 1/2. So 14 is the average value of this function over this interval. Let's go ahead and graph this on Desmos. I'm going to go ahead and do some shading. So I'm going to say y is less than or equal to 0, but less than or equal to, and then I'm going to type in this function, which was 3x squared plus 1. But then let's crop this graph from 1 to 3. So to crop a graph, if you recall, do the curly brackets, and then do an inequality 1 less than or equal to x less than or equal to 3. And we get a shaded portion. Now this is very steep here, so what I'm going to do is I'm going to double pinch the y-axis Or if you're on a keyboard, hold shift while your mouse is over the y-axis and you could change the y scale so we can see this image. Now, according to what we just found, the average value was y equals 14. And let's go ahead and crop that as well. Okay, so here's our average value of this function on this interval from 1 to 3. It's height 14. It's suggesting that the amount of red area above that blue line equals the empty space in white below that blue line, focusing, of course, between x equals 1 and x equals 3. Question 2 is find all values of x in the interval where the function is equal to its average value. So if a function is continuous, then it should cross its average value at some point. To find this without using technology, we simply say, okay, we'll take the average value, which is 14, and set it equal to the function, which is 3x squared plus 1, and then solve for x. So I'm going to subtract 1 from both sides, divide both sides by 3, so we have x squared equals 13 thirds, and then square root both sides. Now this gives me plus or minus the square root of 13 thirds. We actually only want to keep one of these answers because we want to keep the answer that's in the interval. So we want an answer that's between 1 and 3. That's the positive answer here. If you reach for a calculator and decimalize this, you'll get that this value is approximately 2.082. When you're in Desmos, if you click on a graph, it'll find points of intersection with other graphs that are graphed at the same time. So it automatically finds this point of intersection. 2.082 is the x-coordinate and the y-coordinate is 14. The other answer was the negative, and that would be if I actually just graphed 3x squared plus 1 and zoomed out, and I graphed y equals 14, all of it, you'd see technically y equals 14 intersects this green curve twice, at plus or minus 2.082. But we were only interested in finding the x-coordinate that was on the interval from 1 to 3. And there's our average value, and here's the x-coordinate that is in the interval, and here it is in exact form. And that's all we're going to discuss regarding average value.